So, what's the you guys know what a derivative mean, right? What does derivative mean? Finding what?
The
Slope, right? Finding a slope. So what's derivative of a number, like a c?
The derivative of point one.
Isn't it like x plus h minus x? X minus or c x c of x x of c minus x and then x minus c.
He's just
It's zero.
F of c.
Why do you think it's zero?
Because there's no number to base
exactly.
it off
You
of.
can't plug it in.
That's not true.
Oh,
Well-
yeah.
What's this lesson title?
Basic derivative.
Is it just C?
Oh, is it just zero over zero?
Are you the formula or for the actual value?
Think about c is a function. Just think about c is 2. Then what will be that graph look like?
It'd
be x over 1.
C.
C over x.
It would just be zero, right?
It will be just 0, good. Because this is
I know it's
2.
zero, I don't know why.
This is y equal to 2.
Yeah.
What is slope of this line?
Rise over run.
Zero. Oh, it's just a straight point.
Remember, derivative is a slope.
Yes.
So this slope is 0, so derivative of any constant is 0.
Let's
That's what you said, isn't it?
Right?
I said one.
Oh.
So this is called a constant rule. Okay, this is called constant rule. So this is a very, very easy. So you can derivative of e, that's still 0. Derivative of pi, that's 0. Right? So any of those constant, long as they are defined as a constant, they are always 0.
Oh, that's fine.
So what do you think derivative of x?
0.
It's not zero.
X is a variable, it's not a
Oh,
constant.
it's just
It does not exist.
It's just
X.
x.
It's 1.
Wait, is it y equals x or just x?
That seems right. It's just 1.
Because it rises 1 and then runs 1.
Right. Slope of x is 1, right? It's not like a very difficult subject. You always think about graphically. That's why I'm trying to train you guys. Always think about things as graphic. Oh, by the way, the test correction, you can go correct it and can show me. If you're below 70, I usually bump your grade up a little bit higher. So, but the problem, you had to go through the whole test. Okay? Now, if you're above 70, says shouldn't do it, I think you should do it. Even somebody in first period got 100, she missed an extra credit. Just one part of, she got every single part right except the extra credit. And I asked her, says, did you do the correction? She said, no. I said, you gotta go do it. Because you want to understand everything. You want to have perfection in this class, not like semi-perfection, like Luca. I'm just kidding.
Semi-perfection is nice, Mr. Yeah.
Okay, so derivative of x is equal to 1. Now, one more thing so you need to know is today we're going to learn something called power rule, which is something very, very useful. And you're going to use all the time. So derivative of x to the any power, that's just going to be drop the power down, x to the n minus 1. Subtract 1.
It's so easy.
I looked it up on Conic
That's
yesterday. So d over d of x just means derivative, right?
Yep. So derivative with respect to x. Now, one more thing you need to pay attention is this. This here is always on numerator, only on numerator. You cannot say 1 over x to the n. That doesn't work. Because only on numerator. Because a lot of people think if it's on denominator, I can use power rule too. No, you cannot. You cannot. So only the numerator here. So this is super easy. So that right now we can take a derivative of anything now. If I want to take derivative of x squared, then all we do is drop the 2 in the front, and then 2 minus 1. So it'll be 2x.
Oh my god, I love that.
So remember, before you use definition of derivative. See how long it takes if you go definition of derivative. H equals 0, x plus h squared minus x squared. over h. That's equal to limit h approach 0. And this one's going to be x squared plus 2hx plus h squared minus x squared over h.
I don't like this.
This one cancel out. You got to take out h, so be h to 2x plus h over h when limit h approach 0. And then eventually you're going to get the 2x. So the work is much more efficient now. If x to the third power, x to the fifth power, guess what? X to the fifth power is going to take way longer because you need to expand it 5 times. But in this case, we can done in 10 seconds. But guess what? They use the same idea. Is they use definition of derivative and using something called binomial expansion. Do you remember binomial expansion? It's a Pascal triangle.
Oh, yeah.
So you expand it 5 times, like to x to the 5, expand it 5 times. And what happened is all the expansion, all the rest of the term, is all going to go to 0. So only the first term counts, and then that's why you have the power rule. So it's actually, it's a very, very useful information, is you actually get it from definition of derivative. It's not from anywhere, it's from definition of derivative. That's why you will have a quiz on Friday about definition of derivative. It will say only definition of derivative, not anything else.
If I use power rule, can you slide me a pointer too?
Well, if you use the power rule, you know what? I cannot give you credit because it's use definition of derivative. But however, if you're smart, you can double check your answer with the power rule.
That's why.
I wish I had the time to do that.
That way you can take
I definitely won't have the time to do that.
Because I can like
Mr.
finishing the test and just being
Yes.
checking.
Is there any time where the power rule won't work? Or is it like always applicable?
It depends. Like, yeah.
And then you can
Uh,
just relate the fraction.
do you have a pen?
Yeah.
pen?
A pen?
You should just walk around until you find it. Just tell people, be like, I'm Sheila Jamasi. And then just like continue.
Okay, so
We have vice principals?
Same thing.
so you are gonna learn multiple rules from now on. It's always applicable when things situations allow. So a lot of time that you can do, so later on we're gonna learn a lot of rules. So for example, we're gonna learn power rule, constant multiple rule, quotient rule, sum and difference rule, and product rules and chain rule. So we will learn that all next week. However, power rule is always the easiest one to go to if it's presented to you. And we're gonna show you some situation. It seems like it's a quotient rule, but it can be done with a power rule. You just have to know your math a little bit. So let's start with something easy. Let's just say derivative x to the 4th. Then what's derivative of x to the 4th?
Wait, don't say anything.
4x to the power. Yeah.
Just
Why are you guys so bad? Let me try.
let him try. Yeah, so just drop the 4 in the front, and then x to the 3rd, so 4x to the 3rd, and you're done.
That was insane subtraction. Right?
What if they,
We're still gonna write out all this stuff.
what if they give you like 2x?
Then you just multiply it.
Okay, so that's good. So derivative, so
The Khan Academy article told me.
hold on. So let's say 4x to the 5th. Can I take a derivative of this 4x to the 5th? So it turns out there's a rule for this. It's called constant multiple rule. So they say if derivative of c of f of x, that c can be outside, and then just do derivative f prime. So that is very easy. So can I take the 4 outside and just take derivative of the x to the 5,
Oh, and then you
which
multiply
is
by 4.
4 times 5, x to the 5 minus 1 is 4. So it's 20x to the 4th. Does that make sense?
No, but what I was asking about is, like, what if x is like the powerful 1?
X power 1, then that's even easier because 1. So power of 1, right? So you drop that 1, and then x to the 0. Anything to the 0 power is.
So it's 1 times 4.
So also slope of 4x is 4. So that's also another way to think about it, is 4.
Wait, can you only use the power rule for derivatives?
Yes.
Oh, you can't use it outside of the derivative?
No. Okay, so how would I take a derivative on this situation? This is, oh, sorry.
You said when it's 1, it's going to be equal to.
Because x to the power of 0 is 1. Anything to the power of 0 is 1, remember?
Oh, yeah.
That's what we did on the first day.
That is so facts.
So what if you have this case? If you have y is equal to like this, y equal to 2x fifth. Now, how about a second thing? What if you have f of x is equal to 1 over, well, let's just say -2 over x to the 3. So how do I take a derivative in these situations?
You have to rearrange the equation.
Okay, so how do I rewrite this equation? So let's give you some the review of algebra 1. Review of algebra 1 is going to be a to the m times a to the n equal to a to the m plus n. A to the m over a to the n is equal to a to the m minus n, top minus bottom. And this is algebra 1. Anything to the 0 power is 1. The fourth rule is super important, super important. It's called negative exponent rule. A to the negative n is equal to 1 over a to the n. Or 1 over a to the negative n equal to a to the n over 1.
You flip them and you get to swap them.
You flip and change the sign.
That is so facts.
So 5 is this one, we're not going to use it for a while, but we will use it. 6 is definition of derivative, which is a n m is equal to a to the m over n. So those 6 rule is going to be consistently using throughout when you're taking derivative. Now, how would I apply those rules to help me in my favor here?
You could rewrite x as, yeah, that.
X to the which power?
5 halves.
5 half. Now, can I take a derivative?
Yeah, for sure, dude.
So what am I going to get?
I don't know, I haven't done that.
5 over 2 times x to the 3 over 2.
Yep, that's it.
And that's it. You can subtract that fraction on top of your head. Hopefully you can do that. But you'll be good.
You scroll down to the rules again.
It would be x.
And this is on SAT a lot. A lot of SAT classes solve from exponential rules. So that's why I told people you don't even need to go to like I don't know tutor for SAT. Here's the reason being is because somebody in second period asked me, so can I tutor him on SAT? I said no. If you do well in this class, your SAT score will kind of take care of itself because you have to do all those invisible things, native skills that to help you to do SAT. So in some way you will be fine. I mean, you may not score like a perfect score, but you're gonna score pretty high if you got through this class. Okay, so
Khan Academy article.
what?
I saw this all in the Khan Academy article.
Doesn't mean I'm going to do well in the English section.
So now we also look at the rule says what does this says? Only on numerator, right?
Yeah.
But can I take a derivative if they're on denominator?
No, you
Yes,
can't.
you can find the derivative
flip
of
it.
that.
You gotta flip
You
it.
can flip this. Yes, you can rewrite this to x to the negative 3.
So yes, you could do it.
Oh, that said -2 on top.
That's what I was saying.
Bro,
But you cannot take it when that on the bottom. You have to move it. You have to use the exponential rule to move that. So then f prime of x, which is also means derivative, see that y prime, and this one's f prime, it's going to be -2 times -3 times x to the -4.
bro, this is so boggers.
So you drop the -3 in the front, times by -2, and then that -3 subtract 1. So it's going to be 6x to the -4. And you also can rewrite, but it says, well,
Why do we drop
6 over x to the 4.
Wait, why do we drop the 3 in the front?
Because that's the power rule. The power rule says this n is gonna fall into the front, and then the power is gonna subtract 1. So same thing like this. This -3 is gonna drop in the front, becomes multiplication. They're not adding. So this one becomes 6, and this -3 subtract 1 is gonna be -4. So it'd be 6x to the -4. Now you can convert back to non-negative exponents. Does that make sense?
You should give us practice problems now.
Yeah, I'll give you a practice problem. I'm gonna give you a couple, but you gotta pay attention where the parenthesis is. Okay, parenthesis is gonna be the key.
You wouldn't wanna do that.
So
Because that you could pause the exponent. You don't wanna like change the end.
Do I have to ask you to ask back?
That's how I don't think that's even how you write it.
So the first one is this.
Oh.
Now pay attention to between the first one and second one, okay? 2x to the third. So they are very, very small difference. You gotta be careful with so the hardest part of calculus is not calculus. It's actually the algebra that is gonna catch you left and right. So, and if you don't do well in algebra, then you're not gonna do well in calculus. But you can fix it now, which is some of you guys, like Andrew is fixing his algebra skill. I think Caleb is fixing his algebra skills. A lot of you guys are kind of born with that algebra skill, or have very fortunate enough to get a good teacher in the algebra.
Yeah, I had a really bad teacher.
That's
Well,
so sus.
we didn't have a teacher actually.
Is that Wendy Rich?
No.
Go
At Gotha, we that's why we all
That's
suck
why
at
I'm
algebra.
so bad.
They have a-
I actually heard about this.
They got a good pre-calc teacher, but I got like a decent one.
Yeah, Mr. Chaparro taught me algebra.
Yeah, I was gonna say, Mr. Chavarro taught me more math than I've ever learned in my entire
We
life.
should have learned in 7th grade.
Yeah.
It's rough.
I did algebra for about 9. Wait, what?
Okay, Will, you're so great.
Wow, such a
No,
smart.
that's why I don't know. Like,
You're such a star student.
that's why I don't know any algebra.
Okay, so now I wanted to take a derivative of this, but before you take a derivative, please rewrite. Please rewrite them, because if you rewrite them, everything's gonna work out a lot better. Make sure rewrite them to where it makes sense.
Wait, are
So
these separate questions, or are you?
they're all separate questions. They all look very similar between first one and second one, and between third one and fourth one, they look really similar. But derivative is completely different on all of them. The reason being is not calculus. The calculus is always a power rule. It's everything besides calculus. Yes.
When you do the power rule with a negative exponent, do you put the negative exponent in front, or the negative number in front, or is it just regular?
For example, let's say 4x to the -2. If I take a derivative of this,
Is that -2 in front, or?
I'm going to put -2 in the front, and then x to the -3 like this. And I'm going to multiply that. It's going to give you ax to the -3, and it's going to be a over x3. Did that help you?
Yep.
So I will rewrite. I'll spend some time to rewrite this. I won't even do y prime first. I will rewrite this. And on your homework, it was one part, they will say rewrite, derivative, and simplify. So they will actually give you a 3-step process then that you can follow. So here, like, I will rewrite all of them. Rewrite where the x is on the numerator. That's one more thing. But make sure you write correctly.
Yeah, you should let each of us do a different one.
Okay, Anthony, you want to go first?
Oh, sure, I can.
I don't even know if I
You
got
want me to
this
do the
right.
first one?
Yeah, rewrite them first before I differentiate it.
Alright, so I have 5/2 times x to the -3rd.
Okay, now I'm going to take a derivative. See that notation's different?
And then I have -15/2 times x to the -4th.
So 5/2 times -3 times x to the -4.
Yep.
So that's equal to -15/2 x to the -4. Does that make sense?
Yep, and then I have -15/2 x to the 4th.
So now I'm going to rewrite it. So rewrite part is going to be -15/2 x to the 4. Perfect.
I wanna go, let's see even
Wait,
this
I
second one.
need a second.
Mm-hmm.
Is that last part gonna be necessary on our test? Rewriting the exponent?
Depends. So if it's again, really dependent on the format of the test, right? Format's multiple choice, they probably only have positive exponents. So if it's a free response, I understand either one, so I'm not gonna take a point off. So, but it's my test is gonna be the step before that, but then multiple choice is gonna be step after that. So you have to, for me, I'd rather do it all the way to the end. It's not worth to be lazy, but I can see like why some students says I don't want to do the last one. I can save that time and go to the next questions. But yeah, that's understandable, but it just, you have to understand they are equal to each other. So in this class, for whole class of purpose, then we have to make sure we get through understanding first. Yes.
How do you know when you're done with the equation?
How do I know? Then I have positive exponents. I have x to the fourth. But technically, what William says, can I stop here? That's also a right answer too.
Okay.
But it's just not simplified all the way. Yes, Caleb?
Alright, so for the first one, when you simplify it, or not, yeah, when you're trying to get the 2x, you get 2, you do like 1 over 2x to the third, right? And then that's 2x to the negative third, right?
Are you talking about second one or first one?
The first one.
The first one, basically, I only take this move up, not the 2. The 2 stay on the bottom because only the power only apply to the 3. 3 only apply to the x.
Okay, so then for the,
So when you move up, that becomes x to the negative 3.
okay. And so
I actually
for
got
the
that.
second one is gonna be,
Huh?
for the second one, it's gonna be 5 times 2, right?
Well, the second one, be careful because this 2 to the x to the third is 2 to the third as well. So it's actually ax to the third. Because 2 times 2 times 2 is 2 to the third power right there. Does that make sense? And then, now I'm going to rewrite that to 5 over 8 x to the negative 3. Does that make sense?
Yeah, I think
So
so.
the only thing different is a parenthesis. So you have to understand that parenthesis rule really, really carefully. So now I'm gonna take a derivative. So 5 over 8 times negative 3 times x to the negative 4. So that's equal to negative 15 over 8 x to the negative 4, or negative 15 8x to the 4th. So that should be your final answer. Caleb, do you understand? So do you see that parenthesis really make a small difference of your algebra skills right there? Yes.
For the power rule, are you allowed to use it on things grouped by parentheses, or do you have to solve the parentheses first and then?
You have to simplify the parentheses first.
Okay.
You have to simplify the parentheses first. That's the best way.
Okay, cool.
So this one is a negative 2 on the bottom. It's nice because
Easy.
you had to switch up. So it's nice. So be 7 over 3 x to the 2. Now I can take a derivative, then just 14 over 3x. That's it. It's not y squared, it's y prime.
Is the homework just gonna be like problems like this?
Yeah, pretty straightforward.
Awesome.
Um,
This doesn't feel painful.
yeah.
I just realized, can you move the x, when you move the x for the negative exponent, do you bring the term up with it, or are you just moving the x alone and the exponent?
I move this x, move up to the numerator. So technically is like this.
Oh, okay. I was doing the negative exponent thing wrong then.
If you think about it, it's like if you pulled out the whole of x and it was x, 1 over x to the negative 2, and then you just flip that.
I see that now.
That's the way I figured it out. So.
The next one is actually interesting because this one, the whole thing's to the negative 2 power, right? So can I just change the whole thing to the, becomes positive power, become on the top. Now can I rewrite this? It will be 7 times 9x squared. Because now it distributed, it's going to be 9x squared. Then 63x squared. So now y prime is just going to be 126x.
Wow.
So that parenthesis is a very, very fine print. Just like I told you, parenthesis is like a space bar on your keyboard. If you write an article without space bar, that doesn't make sense. It's just bunch letters connect together. So you have to understand where the heck is the parentheses. Okay? So we're going to talk about sum and difference rules like this. 3x squared minus x here. If you take a derivative, it's going to be 6x minus 1. We did this yesterday, right?
Yeah.
And then, so that means derivative of this one minus derivative of this one. Does that make sense?
Wow, that's so easy. I love that.
So if I want to take derivative of this, if I want to take a derivative of 3x minus 2 squared, how would I take a derivative of this?
You have to, you have to do
You
foil.
multiply each of them by 2 and then.
You have to foil first, and then you can do it.
Good job, Luca. Good job, Will. Is you expand them first. So if you expand them first, it's going to be 9x
9x.
squared minus 12x plus 4. Does that make sense?
Yes.
Now I'm going to take a derivative of each one. So that's equal to,
Oh, so we do it for each.
now you do derivative of each individual term. So
18x
18x
minus 12
minus 12
Minus 8.
plus 0, right? Because derivative 4 is 0. I usually don't write it, but I want to show you derivative 4 is 0.
Is that your derivative right there?
That's crazy. Oh my freak. That's
Mr.
awesome.
Gate, the power rule is beautiful.
Is it beautiful?
This is lovely.
It's like playing with cheats.
Wait, you said there are certain instances where we can't use it. Is that what we learned yesterday, like the absolute value and the...
We will talk about absolute value. Absolute value gets kind of tricky. There's a rule for it, but the rule is very confusing. So I won't use that rule. I will always use it in term piecewise. So how do I take a derivative of this one though? So y equal to, that says 3x squared minus x minus 1 over square root of x.
You can. You use phone.
No, I don't want you to do it. I want you to think about from 4th grade. And then I want you to think about also is on my Algebra 1 review sheet.
I got you, sir.
Yeah, Will?
You make square root of x to the 1/2.
Good.
Yeah.
And what else you can do?
The bottom.
And you do something.
You can factor and then pull the bottom.
Well, you don't want to factor. So remember the rewriting process, right? Y equal to 3x squared minus x minus 1 over x to the 1/2. Now remember, in 4th grade you learned this.
Oh, you subtract. Well, you wouldn't subtract, but you subtract the exponents.
In 4th grade you learned this.
Yeah.
A plus b over c equal to a. You learn this way. You learn it from. You learn it this way. You learn this way, right?
The different parts.
Now for me, calculus is more useful to do this way. So now, let me finish this problem. Hold on. 3x squared over x to the 1/2 minus x over x to the 1/2 minus 1 over x to the 1/2. Can I simplify each one?
Yeah.
So that's 3x to the 3 over 2 minus x to the 1/2 minus x to the negative 1/2. Now I'm going to take a derivative. So it's going to be 3 times 3 over 2 x to the 1/2. Does that make sense?
Yeah.
Minus 1/2 x to the negative 1/2
Oh, yeah.
minus or plus 1/2 x to the negative 3/2.
It's
So that is going to be 9 over 2 square root of x minus 1 over 2 square root x plus 1 over 2 x square root
How
x.
does the middle term go from negative x over x to the 1/2?
Because I put this 1/2 drop in the front,
You have to make
becomes
it
a negative 1/2, but 1/2 is going to subtract 1/2.
because
I'm saying, how do you go from like this one to this one? Because when that.
From here to here
Yeah.
is because 1 minus half is half. So 1 minus half is equal to half.